Good evening, class. We are looking at section 3.2, the product and quotient rules. We've looked at the derivative of polynomial and exponential functions, and we're going to go to the new section, the product and quotient rules. Okay, so basically, we are adding some rules here. I want to quickly cover that. Okay. So first and foremost, we have the definition. I hope you realize these two are the same. The definition of f prime of x or dy dx, which is the limit of delta y over delta x as delta x approaches 0, or the limit of f of x plus h minus f of x over h as h approaches 0. They come from the previous sections, and then we are adding this product and quotient rule. Now, I like to use the shorthand notation. And if you have learned this before, you may have a slightly different order, okay? The reason I'm using this order, because it helps me memorize the quotient rule. Here's the product rule. Fg prime is f prime g plus g prime f. However you have learned it, stick with that if you have already. The reason I like this one, because it helps me with the quotient rule. I use the same thing and I put a negative in between over g squared. So that's basically the rule. And we are going to first look at the concept of an analogy with the sum and the difference, that it cannot be used in the same manner. Okay, what do we mean by that? If you let f of x be x and g of x be x squared, by the power rule, the first one gives you 1, the second one gives you 2x, okay? So fg of x is not equal to fg prime of x. In other words, what I'm trying to say is that the sum rule and the difference rule doesn't work here, and that's important to understand. So you can see that doesn't work. And by the way, the product rule over here, it has a different order, and that's fine. But if we stick with the shorthand notation that was explained, okay, and so f prime g plus g prime f, and f of x is x, so f prime is 1 times x squared, plus g of x is 2x squared, so g prime is 2x. And then f is x. I hope you see this is x squared plus 2x squared or 3x squared. And as you see by the power rule, the derivative is such, and that works. So in other words, the formula works. So let's look at the proof here. You're not responsible for the proof, but I like to go over that. By the way, this example says find the derivative both ways. I hope everybody recognizes what we mean by both ways. Number one, by the method of the previous section, first, simplify this. That means multiply the first parenthesis by the second parenthesis and differentiate. By the method of this section, use the product rule. That's the idea of two ways. I want to quickly show you how this product rule and the proof works. So we want to show this is the case. And so let's do that by setting up capital F of x as f times g. Okay, that makes it easy to do. And now it's all about setting this up. What is f of x plus h? That means what is capital F of x plus h, okay? So it becomes f of lowercase f of x plus h times lowercase g of x plus h minus f of x, that means capital F of x becomes f of x times g of x. So that is the setup. I hope everybody can see that, and we have no problem with that, okay? This is basic algebra. And now when you want to prove that, it involves a trick. The trick is that you have to add and subtract f of x plus h times g of x. Okay, so you are adding and subtracting. So first you subtract, then you add. So what happens is that there are 4 terms here, and as you recall, when it comes to factoring, when we have 4 terms, we do them by grouping. Let's group the first 2 and the last 2 together. When we do that, we notice from the first group, f of x plus h comes out. And from the second one, g of x is in common. So let's write it. Okay. So let's apply the limit laws. That means limit of the first piece, okay, limit of f of x plus h as h approaches 0 times the limit of the second piece, this fraction as h approaches 0, the same thing we do with the second part. So we are applying the limit laws. Now, what happens to this guy when h approaches 0? This becomes simply f of x. This is f of x, everybody. What is this one? By definition, g prime. What is this one, g of x? By definition, it's f prime. Okay. So believe it or not, this is the proof. And so what I like to do is to quickly look at an example. I am not interested in simplification for a simple reason. I just want to show you many times in calculus, when we are doing calculus, it is not a lot of steps involving calculus. Normally we have one step and the rest is not. So I'm interested on that one step, the very first step. And I have called the first piece F, the second piece G, to make life easier. So we just want to take the first step. That means we want to do this. Okay. So y prime equals, take the derivative of this piece, okay, which becomes what? 4x cubed minus 6x squared minus 0. We don't write it. So this is f prime times g. Write the second part. Plus, now the second part, take the derivative, becomes 6x minus 5. That's g prime times f. And you're done with calculus class. So here's f prime, here's g, here plus, here's g prime, here's f. Of course, the rest is algebraic techniques to finish it off, and I don't think anybody has any problem with that. But the point of this question is, again, can we do the first step? All right. All right, we want to work on this using, obviously, the product rule. If it helps, you can put a raised dot between x and e to the power of x. And so you notice you are using the product rule. Therefore, the derivative of x times e to the power of x, how do we come up with that? X gives you 1 times e to the power of x, and e to the power of x gives you e to the power of x times x. And you're done with calculus, factor e to the power of x, and just rewrite it, and that's the end of this story. Now, I want to differentiate it again, okay? I want to differentiate it again. So, again, let's use the product rule. The first piece is e to the power of x, so the derivative is itself times 1 plus x, plus the second piece is a parenthesis that gives us 1 times e to the power of x. And again, we're done with calculus. So I hope you realize that if you factor out e to the power of x, then the first one gives you x plus 1. The second one gives you plus 1, leaving us with x plus 2. So e to the power of x times x plus 2. I hope everybody's clear. This is really not a big deal, everybody. All right, having said that, let's quickly look at the proof for the quotient rule. Again, you're not responsible for that. And to do that, again, to make life easier, let's call capital F of x f over g. And let's apply this. Let's apply this definition into in capital F of x. Capital F of x. Okay, so that's capital F of x. Now, what is capital F of x? So lowercase f of x plus h over lowercase g of x plus h minus capital F of x, f over g over h. We take a limit as h goes to 0. So I hope you can go from this step to this step, which is purely algebraic. Okay. Now, let's multiply the top and the bottom by LCD. I hope you realize you have to multiply the top and the bottom by g of x times g of x plus h. Let me write it here so you see, because I I don't have room. I'm going to write it here on this side. We are going to multiply the top and the bottom by g of x times g of x plus h to get rid of what? Complex fraction. So what happens? It becomes a simple fraction. The top becomes f of x plus h times g of x minus f of x times g of x plus h, and the bottom has h and also gets these two factors. So h times g of x plus h times g of x. Now, let us again use a trick. We are going to add and subtract something. In this case, we're going to add and subtract f of x g of x. Okay, again, here's the trick. When we do that, we end up with the previous situation. We have 4 terms in the numerator, and that means factor by grouping. We put the first 2 together, we put the last 2 together, and let's see what happens. So if we look at the first 2, okay, I hope you realize g of x comes out. So g of x times f of x plus h minus f of x, okay. If you factor the last 2, okay, f of x, okay, times g of x minus g of x plus h, or if I put a negative here, then this comes first, okay, so f of x times, so maybe I put that at top so everybody can see. I can rewrite this top as, okay, minus, and I'm going to put this guy first, f of x times g of x plus h minus f of x times g of x, and I can factor the common factor of f of x out. Now notice the denominator is h times g of x plus h times g of x. So what I can do, I can leave it just the way it is. I can leave the denominator just the way it is. Or if I bring the h up and make the denominator of those expressions, that means absolutely the same thing. In other words, I'm putting these 2 together and I'm getting those. And then I'm bringing this h up. I hope you realize if you multiply the top and the bottom by h, you get this expression and h goes down. In other words, we are going to reverse the process of a complex fraction and go back to a complex fraction. Okay. Now let's apply the limit to the top and to the bottom. So what happens? When we apply it to this one and to this one and to this, term, this gives you simply g of x. This is the definition of f prime minus, this is f of x. This is the definition of a g prime. What about the bottom? This piece becomes g of x. The second piece also g of x. So g of x quantity squared. So again, believe it or not, this is the proof. Again, I don't expect you to do that, but I do expect you to be able to follow that. Now, here's a simple example. We are using quotient rule where the top is f. In fact, literally you can put this as f over g. So you see that this is f and this is g. Again, if it makes it easier. So f prime g. So f prime, the derivative of the top is 2x minus 3 times x minus 1 minus g prime, the derivative of the bottom is 1 times the top over the bottom squared. And believe it or not, you're done with calculus class. This is it. Calculus is done. So what do you do now? You use your algebraic techniques to finish the job. That means you have to FOIL this, you have to apply the negative, put them together. So when you FOIL this and you apply the negative, this is what you get. I'm assuming nobody has any problem with FOILing. So now the top, we can combine them into the following. And notice we didn't touch the bottom. The bottom is simply x minus 1 quantity squared, and we keep it that way, and we are done. Okay. It's important for everyone to know that there are times that we must use a quotient rule, and there are times that we don't have to. If you must use the quotient rule and you try to avoid it, is it doable? Yes, if you're very careful, it is doable. But it's really not a good idea. Normally it takes longer time and normally students mess up. On the other hand, if you don't have to use the quotient rule, it happens the same. Here's an example that there is no need for a quotient rule because all you have to do, just write this as t to the power of 1/2 and make up two fractions. In other words, use your algebra. I'm hoping nobody has any problem with the algebra and everybody's understanding what I'm doing here. I'm making up two fractions and the square root of t is being changed to t to the power of 1/2. Okay, algebra continues. This one is t to the power of 1. So 1 minus 1/3 is t to the power of 2/3. And minus t to the power of 1/2 minus 1/3, which is 1/6. Okay. So just in case, I'm using a to the power of m over a to the power of n is a to the power of m minus n. And just dealing with fractions. So now, let's differentiate. So I hope you see we did 2 steps of algebra. We haven't done any calculus yet. Let's do calculus. Differentiation. So the power rule, 2/3 sits in front, t to the power of 2/3 1/6 sits in front, t to the power of 1/6 minus 1. Now, 2/3 minus 1 is negative 1/3, and 1/6 minus 1 is negative 5/6. We don't like negative exponents. We take them down, we make them positive. Do we have to change them to a root format, radical format? The answer is no, because the way it was given, you had both of them, so it doesn't matter. Either way is fine. Okay. All right. Again, you're looking at the product rule. This is square root of x times e to the power of x, and we better change square root of x to x to the power of 1/2. So we change that. And again, if it helps, let's just put a raised dot just to emphasize we are using the product rule, everybody. Product rule says f prime g plus g prime f. The first piece is x to the power of 1/2. We're going to differentiate that. 1/2 x to the power of 1/2 minus 1, which means negative 1/2, times e to the power of x. Plus the second piece, the derivative is itself times x to the power of 1/2. All right, let's rewrite this. X to the power of negative 1/2 goes down, becomes positive 1/2, and it's the square root of x. Okay. If you left it as that, it's fine. If you factor out e to the power of x, it's fine. If you factor out 1/2 square root of x e to the power of x, you get 1 plus 2x. And this type of factoring is a must because later on we are interested in finding zeros of the derivative functions. Okay. And to see how it's done, maybe I'll quickly show you in case as far as the algebra goes. Class, when you're here, you can say the common denominator is 2 square root of x. So I hope you realize that the first piece is simply e to the power of x plus the second piece is e to the power of x e to the power of x square root of x times the denominator. So we are taking a common denominator. So the first piece remains as e to the power of x. The last piece becomes 2x. So this as e to the power of x plus 2x e to the power of x over 2 square root of x. And I hope you realize you can rewrite it in this manner. Okay, it's just a couple of steps of algebra involved. All right, let's do differentiation, and this requires the quotient rule. So the quotient rule indicates that we have to, okay, if the top is f, the bottom is the g function, okay? So the derivative f prime g, the derivative of the top is e to the power of x times the bottom, minus the derivative of the bottom is 1 times e to the power of x, over, just write the bottom squared. So you don't have to really do anything for the bottom, just square it, that's all. Now, practically, and this is it, you're done with calculus. Now we have to do our algebraic techniques to finish this by rewriting the numerator as follows. We are going to multiply, let's do that quickly, and this results in e to the power of x plus e to the power of x times x. So I hope you realize that e to the power of x and minus e to the power of x, they cancel each other. So we just write whatever is left. Here's another example, similar. Okay, again, we are using the quotient rule. So what do? We take the derivative of the top, becomes e to the power of x, times the bottom, that's f prime g, minus the derivative of the bottom is minus e to the power of x times the top. So when you apply e to the power of x to this, let's write it at the top of it quickly. Okay, so this becomes e to the power of x minus e to the power of x times e to the power of x is e to the power of 2x, and this is plus e to the power of 2x, and so you're left with the first piece only, and that's your final answer. We want to find the equation of a tangent line. We need to use the quotient rule. First and foremost, we need to find the derivative, and then we plug in number 3 to find the slope. Remember, in order to find the equation of a tangent line, you need a pair, it's given, and the slope. So the derivative is very straightforward. 1 times 2x minus 7 minus 2 times x over 2x minus 7 squared. And I hope it's clear that this is 2x minus 7 minus 2x. They cancel each other. The numerator is left with negative 7. We're done as far as calculus is concerned. Plug in the x coordinate, which is number 3, and find the slope. I'm assuming everybody can quickly do that. Y minus y1 is m times x minus x sub 1. This is a point slope we are going to use. So y minus negative 3, that means plus 3. M, that means minus 7. X minus 3, and simplify, and this is what you get. By the way, the pair works for the original function. It should work for this tangent function also. We want to try this. On purpose, I have used a different variable. Normally we use x and sometimes t, even theta. But on purpose, I'm using something different just to make a point. Whatever the independent variable, so be it. In this case, the independent variable is m. How do we know that? Because it says f of m. So having said that, the quotient rule, 9 times the denominator minus 5 times the numerator over the denominator squared. Okay, over the denominator squared. Now, this is actually a pretty straightforward class.
Hey, Professor, I have a question.
Yes.
On the left-hand side, on a second from the top, it says minus 2 yeah, -2 times x. How'd you get
Yes.
that?
I'm looking at g prime f. Take a look at the formula. We have f prime g minus g prime f. The numerator is the f function. The denominator is the g function. So the denominator, when you differentiate it, you get 2. So
Yeah.
f prime is 1 times 2x minus 7 minus g prime. In other words, let me just write it in this fashion. We call this f, we call this g. So this is f prime g minus g prime f, and this is g squared. Does that make sense?
Yeah, and in the prime. Never
What
mind.
this is, you're okay with that, right?
Yeah, sure. Never mind. Thank
Perfect.
you.
My pleasure. So therefore, and as long as you can do the differentiation, the rest is pretty straightforward, everybody. The main part is the differentiation, remember, because that's the part that involves calculus. And I hope everybody's comfortable with that. Let's quickly recap the second question. First and foremost, the independent variable is m, and the reason it is because it says f of m. Now we're going to go with f prime g. That means the top is the f function. Let's again write next to it. So this is f over g. Okay, again, we're using the shorthand notation. It goes faster. The derivative of the top is 9 times the bottom. Minus g prime, the derivative of the bottom is 5 times the top. Over g squared, just write the bottom squared. And so therefore, all we have to do is simplify this as follows. Distribute, okay, distribute. 45m plus 36. Now the next one is minus 45m plus 35. I hope you realize the only thing left in the top is the numbers, 36 and 35, they add up, and we have 71. All right. So the quotient rule. You want to look at this question. We are asked to come up with the equation of a tangent line as well as normal line. So we're going to discuss the normal line in a moment. First, let's just ignore the normal line, come up with the equation of a tangent line. Okay. All right. To do so, what do we have to do? Well, let's differentiate. So y equals square root of x over 1 plus x squared. The very first thing we do, square root of x, we change it to x to the power of 1/2, because this way it makes life easier to do. Okay. Now we want to differentiate this. F prime, remember the top is the f function, the bottom is the g function, so we need the derivative of the top. 1/2 sits in front, x to the power of 1/2 minus 1, or negative 1/2 times the bottom, minus the bottom gives you 2x times the top. And just write the bottom squared. So I hope you realize that we are done with calculus. Now, there's a lot of algebra involved, but we are practically done with calculus. So I'm going to quickly recap to make sure everybody's comfortable with that. The top is x to the power of 1/2. Its derivative is 1/2 x to the power of negative 1/2 times the bottom. Minus, the bottom gives us 2x times the top, and you're done. The bottom, you just write it squared. Okay, so having said that, how do we fix this? Well, take a look at what you have. In essence, you have a complex fraction because you have 1/2 here, so you need number 2. You have x to the power of minus 1/2. That means you have square root of x in the denominator. So you need x to the power of positive 1/2 or square root of x. So we are going to multiply by 2 square root of x or 2x to the power of 1/2, the top as well as the bottom. This is algebra class. So what happens to the denominator? Nothing. You just write this one, you put the 2 in front, and you write this as square root of x. Here's it. I mean, that's another big deal. But let's see what happens to this. If you multiply this by the first piece, I hope you realize the product of 1/2 x to the power of minus 1/2 and 2x to the power of 1/2, their product is 1, everybody. What about the product of these two? Minus 2 and 2, 4, their product. X, and then x to the power of 1/2 and x to the power of 1/2 is x. X and x gives you x squared. So I hope you can go from here to here. This is purely algebraic class. Now, the numerator becomes 1 minus 3x squared. Okay. The next step, find the slope. Now, before we move on, I hope everybody can follow this. This is very straightforward, everybody. Okay. So I'm going to recap, making sure everybody's okay with that. The derivative of the top, 1/2 x to the power of negative 1/2 times the bottom, minus the derivative of the bottom is simply 2x times the top, and you just write the bottom and square it. This is a complex fraction. Because of 1/2, we need number 2. Because of x to the power of negative 1/2, to undo it, we need x to the power of positive 1/2. We do that to the top and the bottom. Multiplication by this one cancels it and gives you 1. Multiplication by this one gives you minus 4x squared. Now plug in the x coordinate, which is 1, and that gives you the slope of a tangent line. I'm assuming everybody can do the calculation class. I'm assuming everybody's okay with that. Plug in number 1 into this. That gives you the slope. Now y minus y1 is m times x minus x sub 1. And everybody can do the work. I wouldn't worry about that. Y minus y1, that means y minus 1/2, equals m, that means negative 1/4, times x minus x sub 1, that means 1. Okay. If you apply, you get negative 1/4 x plus 1/4. Okay, class? And then you move the negative 1/2 becomes positive 1/2. So this is nothing brand new. But what is a normal line? By definition, normal line is a line that is perpendicular to the tangent line. So what does it mean? Well, we have the slope. If the slope is negative 1/4 for the tangent line, what is the slope for a line which is perpendicular to that? Negative reciprocal. So negative reciprocal of this number is 4. So now you have the pair 1 and 1/2 with the slope. I'm going to call it m sub 2, which is 4, and you are going to come up with the equation of a line. I don't believe anybody has any problem with that. Y minus 1/2, let's just write it. Equals 4 times x minus 1, and that's how we arrive at the equation of a normal line, everybody.